Welcome, everyone, and thank you for joining early. We'll get started soon. We'll just wait for a few more people to join us. Hello, everyone, and once again, thank you for being prompt. We shall be getting started in just a few seconds. Okay, hello and welcome, and thank you for joining our webinar entitled Why Code Quality is a Compliance Accelerator. If you have joined any of our previous webinars, hello again and welcome back. And today we'll be asking, how do the core components of code health directly strengthen your compliance posture? I'm Andrew, and I'll be your moderator today, and I'm excited to have Ekaterina and Simone with us as presenters today. But before we begin, let's just quickly go over some housekeeping points. So the session will last around about 45 minutes, and we'll have a time of Q&A at the end. And you are invited to submit your questions at any time during this webinar via the Q&A tab, which you'll see at the top right of your screen. And we'll endeavor to answer as many of those questions as possible live. We have Geoffrey behind the scenes who's working on these. So do feel free to submit your questions, like I say, at any time and not wait until the end. Plus, you can upvote any questions you particularly like to see answered. The session will be recorded, and we'll send out a link via email to that recording in the next few days. And finally, a brief 4-question survey is available for you to take at any time. You'll see that up the top right as well, and your input will help us improve, and we appreciate your feedback. The last thing to say is we will be having a demo time at the end, so stay tuned for that. And now I'd like to introduce our presenters. So we have Ekaterina, who's here from our product marketing team, and she brings a wealth of experience in business-to-business SaaS for regulated sectors and focuses heavily on crafting use cases that simplify the adoption of strict requirements. And then covering the technical and strategic side is Simone, one of our product managers who oversees our enterprise-grade capabilities. She has spent the last 6 years working in cybersecurity and enterprise platforms to build solutions that solve governance and reporting challenges for large-scale organizations. So thank you to you both. And Ekaterina, over to you.
Thank you very much, Andrew. Hi, everyone. I'm Ekaterina, and as Andrew has mentioned, prior to joining Sonar, I was a part of multiple businesses that work in life science space, so compliance comes naturally to me, and I myself see it not as much of a challenge, but more of a task that we have to accomplish on a daily basis, because whenever we think about life science and software development and any sort of regulated industries, it's not something that we consider boring tasks that we have to accomplish. It is a business reality that we have to respect. So let's quickly go through the agenda for today. On our roadmap is the first we'll look at the responsibility model in software development lifecycle compliance. Who is responsible for what? Developer versus business. Then we'll move to the criteria for high quality code and what regulations say about it. We will go in depth in some global and local industry local regulations as well. We will definitely cover AI because AI is a big change in software development lifecycle and in its compliance, enabling mechanisms and how we can solve them. And then we will go to demo and Q&A. But we'll start with a poll. So, if you were to present an evidence of the fact that package contains no black balls, which image would you prefer for that? I will give you a minute to answer the poll, and I will get to the context of why we're asking this question. And a few more seconds. Okay, so the majority of people who took the poll picked the image number 2. And this is what I wanted you to pick, obviously. And the reason for that is whenever we actually look, both packages have no black balls in them. However, the structure, the organization that's provided with the image number 2, um, if we step into auditor's shoes and we look at those two things, if an information is presented, if the evidence for the audit is presented in a structured way, it's generally much easier to assess it, not entirely, but kind of like assess the playfield that you have and lay out a plan for the audit if you don't have to dig much. And this is what high code quality does for you and for the code base. It provides the structure for auditors to be able to assess your compliance in a more streamlined and simple way. So that's the main reason that we will be talking about it. In terms of the compliance responsibility model, developer versus business, it is important, and for my point of view, it's the easiest way to navigate the compliance and software development lifecycle by dividing it into two distinct domains. So there's the code-related domain on what is built, and environment-related domain, the foundations built on. What is built is the developer's domain, and what developers is directly responsible for. It's maintaining code quality, preventing vulnerabilities, taking care of security issues, managing access controls, managing dependencies, and audit trails. However, with the majority of regulations, as the regulations are more framework related, more focus goes into the business domain, the foundations built on. And it's split, from my point of view, into two domains, two subdomains. Technical domain, subdomain, the platform, which relates to configuring, managing infrastructure, access management, identity management, providing developers with adequate tooling and pipelines. Specifically, whenever we're thinking about compliance in the regulated industries, the requirements will be generally much higher than the baseline. So the infrastructure setup and the tooling with pipelines is something that business have to really think about. And administrative, the process, because on top of the infrastructure, we have the standard operating procedures, all of the documents that serve as evidence for compliance. And this is also something that business have to think about. How they create and manage formal governance, how they create and manage procedures, training, and oversight. Moving on to high quality criteria, at Sonar, we define high quality criteria as reliable, secure, and maintainable, and in compliance perspective also defensible, because reliable code functions as intended without failure. It performs consistently all required functions. It has high test coverage, and it helps to identify bugs early. Secure code actively defends against attacks. Maintainable code can be fixed and updated easily in a timely manner. And defensible code, why we added for compliance, is that it can prove it did the right thing, which is the essential component of any sort of the audit. Every time a developer writes high quality, testable, maintainable code, they are directly supporting the organization's ability to stay compliant. And this is, again, one of the big parts why we look at high code quality as one of the accelerators for compliance, because it's the part of the daily work that can be used as instead of compliance being a stopper for your velocity, is a natural process whenever you're focused on high quality code instead of highly compliant code first, and then it makes compliance not simple but simpler. And we are moving on to what regulations say about it. In terms of reliable code, global regulations all mention reliable code in some extent. For example, GDPR mentions that there should be implemented appropriate technical and organizational measures. CRA mentions the product must protect the availability of essential functions, including the resilience against the mitigation of denial of service attacks. And NIS2 directive mandates business continuity, backup management, disaster recovery, and crisis management. And industry regulation, as you can imagine, also touch upon that. DORA specifically says that financial entities must maintain a sound and comprehensive digital operational resilience. NIST ESP 853 requires contingency plans, and IEC 623 or 304 asks manufacturers to establish acceptance criteria for software units and verify the system foundation as attendant. And what it all means is that in a way or form, major global and industry-related regulations are talking about code reliability. And actually, there are examples of what happens where code reliability is not in place. So there is a major bank that's migrated millions of customers to a new platform without, unfortunately, doing a sufficient resilience testing. It's a well-known case where the system collapsed under the load. It locked out customers out for weeks, and it then resulted in a fine of 48 million pounds, where regulators explicitly cited operational resilience failings and lack of rigorous testing. Moving on to security. Security is the core of any sort of compliance requirements. Compliance is mainly built around security, so we won't be going into deep details on what regulation says about it. Regulations say a lot about security, but again, as an example, that GDPR, for example, explicitly says that processing data to maintain network information security is a legitimate interest. UCRA also mentions that the product with digital elements must be available in the market without known exploitable vulnerabilities. SOC 2 also touches on that there should be vulnerability scans and actions to remediate identified dependencies. With, again, as I mentioned, security is the one of the main cores for everything. So multiple industry regulations mention that you should prevent common vulnerabilities. You need to forbid using for production data for testing. You must use the secure development framework, define security quality standards, set vulnerability analysis, etc. So it's kind of like, I would say that security is the thing for whenever it comes to compliance. We first think security. And the real life example again, so a global credit bureau was breached, exposing 147 million records, with the root cause a single known vulnerability in the person's framework. It went unpatched, unfortunately, because the team lacked a proper inventory. This case resulted in a staggering 575 million settlement for the company. And what's interesting is that failures like this were one of the catalysts for US government to mandate standard bill of materials for all government vendors. So cases like this remind us about one important thing, that compliance, even though it seems boring sometimes, it's very expensive when it goes wrong. So good setting for compliance is that when you have no issue, having no issues in compliance, I would say, is a very difficult task, specifically for a big business. However, um, it attention that it requires pays out when everything is right. Maintainability is next, and the requirement for maintainability that it can be fixed and built safely. And I would say that major regulations approach maintainability from a way of that they require you to be able to quickly react to issues in your code base and the requests that they have when it comes to data privacy, data security, etc. So, for example, GDPR requires the ability to restore the availability and access to personal data in a timely manner in the event of the physical or technical incident. And there's also the right to be to be forgotten in GDPR, which also has timeline mandated for the deletion of the personal data records outside of your database, which would be fairly either really hard or impossible if the code base is not maintainable and it requires for you like 48 hours instead of 4 to do an update. It possesses a direct violation of a certain regulations. Cyber Resilience Act also asks manufacturers, for example, to ensure that vulnerabilities can be addressed through security updates. And ISO ISAC 25010 defines maintainability as the degree to which a system can be modified effectively, and it requires analyzability, modifiability, and modularity. And in terms of industry regulations, finance, I would say, is probably one of the biggest ones when it comes to maintainability with PCI DSS version 4.0 requiring critical security patches that must be installed within 1 month of release. DORA requiring that financial entities must have procedures to ensure all ICT challenges that are recorded, tested, assessed, approved, and implemented in a controlled manner. And IEC 62304 asking manufacturers to establish a software maintenance plan and analyze every change request to determine its impact on safety and effectiveness before implementation. And when it comes to um, regulations like, for example, in automotive industry or in airplane industry, it also a big maintainability makes a big impact there. Example we have on maintainability is actually a very interesting one because it's also motivated regulators to make a change. So, a global hospitality giant acquired a rival hotel chain, inheriting their guest reservation database. And the inherited code base on its own contained a hidden vulnerability that went undetected for 4 years because the acquirer failed to migrate or modernize the legacy system in a timely manner. The breach exposed 339 million quest records, and it resulted in the UK Information and Commission's Office finding the company 18.4 million pounds and establishing the precedent that organizations are legally responsible for the maintainability and security of all code they acquire, not what just or what they just write themselves. Which again sets an interesting precedent that's been in the industry for years now. And we're moving to the last code quality criteria, defensible code. The requirement here is that, again, you can prove that the code did the right thing. And if an auditor asks how the customer data is protected, the code and its logs is the primary evidence for that. I would say that, again, all regulations, major regulations are pretty much on the same plane with that. They're asking that logs that record user activities, exceptions, faults, and information security, they shall be protected, produced, kept, and regularly reviewed. And for example, EU CRA asks that the product must record information on the internal state and security level events to verify the security of the product. And in life science, for example, it's a very big thing when it comes to audit trails and audit logs, specifically because I would say that every preparation for the audit that we had started with the review for the audit trails that we had, if like checking if everything is in place. And we paid an insane amount of attention to the quality and readability of our security logs. In terms of industry-specific regulations, again, finance is the one of the easiest industries to find good examples for because financial regulations are very thorough and detailed, and they update quite frequently. So, for example, PCI says mandates logging all accesses to hard-coding data and invalid access attempts. Logs must be secured so they cannot be altered. DORA requires logging capabilities that ensure post-incident analysis to help identify root causes for disruptions and needs to be 853 requires that system must generate audit records for specific events and capture the who, what, when, where, and outcome of every action. So, what about AI, you may ask? In terms of AI-assisted or generated code, it faces even greater scrutiny than developer-written code due to a number of factors. One is that AI-generated code often trusts inputs, and you'll need to verify that it validates all inputs and encodes all outputs to prevent security vulnerabilities. In a recent survey that we have done, 61% of developers were saying that AI often produces code that looks correct but isn't reliable. So that's when it comes to uh, validating all the inputs and validating all the code and re-verifying all the code that we have generated or assisted by AI. AI generated logs are often just technical noise. AI tends to be quite verbose when it comes to generating any sort of code. So we need to ensure that logs provide a meaningful who, what, when audit trail for security events, and they're not just the collection of blabbery around what AI is thinking a good log can look like. AI-generated code also frequently omits authorization. AI-generated or assisted code is no stranger to hard-coding passwords, access details, or something like that. So we need to ensure that it checks user permissions on every request and not just notification. Um, Sensitive data handling, as I mentioned, the AI can hardcode secrets, and a reviewer for AI code must hunt for it specifically and make sure that sensitive data is never locked. 57% of developers that were recently surveyed were concerned about AI um, leaking sensitive data of the organization customers. And last but not least is again audit trail verification, because AI is not too good when it comes to generating logs, so we have to be extra careful with that. We have a poll number 2 on our hands. So, in terms of the capabilities for automating technical compliance, which one would be a top priority? Uh, option 8 is the pre-built templates that are ready to use, standard-specific reports. It could be SOC 2, ISO, or any of the industry-specific regulations I just mentioned, directly within the dev tools. Or option B is the compliance tool integration with seamless data syncing with dedicated compliance platforms like Vanta, Audit Board, etc. I will again give you a minute. Perfect. Thank you so much. So, for the majority of the people who voted for pre-built templates, we have some good news for you. But actually, we have a lot of good news for um, both sides of this survey, and actually both sides of the software development lifecycle and compliance that we mentioned before, when it splits to developer-led compliance and the business-led compliance. And we will talk now about the enabling mechanisms that can help you streamline compliance in your software development lifecycle. With the first one being standardization. Um, One of the main features of standardization in compliance is that you will be able to ensure that all regulated requirements are enforced automatically and continuously and applied on the same level to all people that have to be compliant to them in your organization. So there's no tooth pro, there's no like wondering what teams uses what teams apply to what, etc. It guarantees you that all code is compliant before it ever reaches production. So the options that it could be, one is quality gates that define non-negotiable pass-fail criteria, and for all new code must meet before being merged or released. The second option here is automated PR scanning, which automatically analyzes new code on feature branches, pull requests that applying quality gates and rules immediately. And the third option here is the quality profiles that synchronize a consistent set of code quality and security tools across all projects, IDEs, and CI/CD pipelines. Uh, Standardization is something that we are thinking a lot, specifically when it comes to large regulated organizations with multiple teams working on hundreds of projects. It's one of the main challenges that developers from regulated industries mention whenever we talk about compliance and ensuring that the standards are consistent and they're spread across the organization. Because with in a lot of regulated industries, legacy code and the very old historical code bases is the thing that you have to maintain, that unfortunately sometimes due to compliance requirements you cannot just abandon and move on to shiny new thing, which is not normal practice for everyone, I hope. But in compliant and in regulated industries it's specifically bad, and it's like it's frowned upon basically. So whenever there is an option to standardize and make sure that the new code that's developed is following the same rules without regardless of where it is coming from, is a very big enabling mechanisms for both developers and business sides. The second mechanism is a testability, basically to reduce operational risks and achieve audit readiness by automatically generating verifiable evidence of compliance across your entire software portfolio. Is to be comes back to what we're talking about when we're talking about code defensibility, to be able to prove that your code did the right thing, and that it complies to the regulations that you need to be compliant with. So the first mechanism here is obviously regulatory reports. When you generate security reports and compliance reports aligned with major industry standards like WASP, CVE, CWE, PCI DSS, SIG, etc. The second is AI code assurance that subjects the AI generated code. Coming back to again to what we're talking about, that AI generated or assisted code has to be subject to the same or more rigorous quality and security review as developer written code, and portfolio management and executive reports that provide high-level visibility into code health, security status, and compliance trends across the entire application portfolio. I would say that portfolio management and executive reports is more for the business side of the conversation, to be able to keep a helicopter view on the status of your projects, on the status of your code base, and also to be able to use it as a touch point for whenever there is a need to assess the readiness for the upcoming audit or any sort of a review that you may have. Last but not least is automation. Automation helps to find and fix compliance issues instantly, your workflow, transforming it from a bottleneck into the continuous learning opportunity and development factors. So first is a start left SonarQube for IDE that integrates real-time static analysis and synchronized quality standards directly into developers' local environment. A second is AI code fix that uses AI to automatically suggest and apply fixes for issues detected by SonarQube or any tools you may have in your pipeline, and actionable remediation guidance that provides clear issue descriptions, examples of compliant code, and the why behind each violation. And again, here I would say that with the extreme growth in amount of code that AI helps to create, actionable remediation guidance is something that really helps to support the growth in productivity in generating new code, support it in the reviewing the code that's been generated. Because whenever we talk about AI generator assisted code in any industries, not just regulated industries, we can safely assume that with the uh, if we used to generate 50,000 lines of code and now we generate 500, there will be a need to review the 500 instead of 50,000, 500,000, sorry. And unfortunately, the human capabilities are limited at that. So we need to get all the help that we need to make sure that nothing slips through the cracks when it's very important. And now to the demo time, and I will give it to Simone.
Yes, thank you so much. I hope, yeah, everyone can hear me. So, just 1 second. Emma, are you there? Hi, everyone. Thanks for your patience. I just had to figure out these buttons here. So looking forward to sharing a demo of compliance here with you guys. So you heard a lot about this topic from Ekaterina already. Let me show you how this can look like inside the product. So here what you're looking at is a project that I have. It's called Juice Shop. It's got a bunch of different security issues in it. It's an app that I'm working with. And what you see here on the screen is the overview of the project. And here you can see the current health and compliance posture of this project. Everything you see on this page is derived automatically from code analysis that runs on every change to the project. And there's no separate compliance workflow here. This is the workflow itself. So from a compliance perspective, this answers a first basic question. Do we have visibility into the state of our software right now? Now, the natural follow-up question is who defines what compliant actually means? And that responsibility typically sits with a platform, security, or compliance team, and not necessarily individual developers. So here, moving over to the policy, which we find at the organizational level. So here in my organization, I can find quality gates. And here's where we can define the policies that we want for our external or internal compliance policy needs. These can become non-negotiable policies that apply consistently across projects. What's important from a compliance standpoint is that this ensures consistency. So every project, every team in my organization, every repository is going to be evaluated against the same baseline. It's an enforceable policy that determines whether code can move forward. It's very strict of yes, no, green or red. And once it's defined centrally, it's applied automatically. No team by team interpretation needed. Let me quickly show you how a potential compliance gate could be created. So let's say that we have the SonarWay default built in here. What I can do, which is recommended and also standard for most default quality gates in the product, I can just choose to go here to copy. And let's say that I call this compliance because I have a few conditions that I'm very keen to introduce. And here, as you can see, this gate is going to have conditions based on various measures. The standard SonarWay default quality gate is based on some conditions on the new code. So these are coverage, duplicated lines, related to not introducing any new bugs, not introducing any new security issues into the code, and so on and so forth. And what I will actually do here, just as an example, is even create a condition on the overall code. And let's take vulnerabilities for the sake of an example. And let's say that we should have no vulnerabilities on the overall code as one of our policies. And you'll see it pop up here. So what matters here is not the exact thresholds, but the principle. So compliance standards are defined once, centrally, and applied everywhere. By going to the projects, I can see and select all the different projects I want to include. For now, I'll just choose the one project that I am demoing, and voila, it's applied. So this setup is typically owned by a central team. It could be platform security or compliance officers or other administrator level roles in the organization. So now we've defined the policy. Let's see how it actually works on our project. So going back to my projects, I'll look for my Juicy app. And let's see what it looks like in practice. So I have pre-run this analysis for the sake of this demo. And here you can see that on the main gate or the main quality gate, we have a failed status. So when the condition fails, in this case related to vulnerabilities, the project is clearly marked as not meeting a defined standard. So this is where different personas can interact with the same signal, but in different ways. So let's zoom in on the conditions. A developer looking at this doesn't have to guess what's wrong. They can click directly on the failing conditions and immediately see a filtered list of the exact issues that caused the failure. So this is important. Developers don't work at the level of policies. They work at the level of concrete issues in the code. And this quality gate tells them whether the code can move forward or not, and the issue list tells them exactly what to fix, and even how to fix it or why things are an issue. In this example, the failing condition is related to security, so let's follow that path. Each security issue is also mapped to the context of a standard, for example, OAuth, CWE, and this is where alignment between developer and compliance happens. Developers see actionable guidance. Security teams see structured standard-based evidence. So both are looking at the same underlying data, just through different lenses. And individual issues are useful day to day, but compliance is, of course, about proof at scale. And this is where security reports or various compliance reports come in. Going over here to the project level security reports, we can see the posture or the security and risk posture of this project. We see that there are certain issues, and on the left, we find all the different types of categories, all the different standards and categories related, and where issues are found in the code. It's possible to download the security report, whether taking the default, we know that a lot of our customers follow the OWASP and CWE, or you can custom select various standards depending on what you're interested in. And this is the type of evidence security teams and auditors typically ask for. And the key difference is that it's generated continuously with every commit, with every change to the code, and doesn't need to be assembled manually. And security is just one part of the picture. If we go back to our project overview here, or to our main branch summary, this is also useful for audits and external reviewers or even internal governance processes. If we go to our reports in the project, we can find regulatory reports here as well. So this provides a more consolidated, exportable view of compliance-related findings for a specific branch, typically the main branch or release branch. If you go to project information, you will also be able to find it here and choose different branches in case you have multiple available. And this helps you download an entire report with a summary PDF, CSVs, with all the different issues inside the report and the quality gates and quality profiles that were applied. That gives you a snapshot of the compliance at a specific time, and is, of course, backed by continuous analysis. So going back to our project, we've covered how the developer can interact. We've covered how compliance policies can be set. And another interesting fact I'd really like to share here is that from a security perspective or security lead or compliance officer, or even from a lead perspective, imagine if you went into a summary, you have overall code failures, you have some vulnerabilities here. You can also choose to push these directly into the developer workflow and potentially attach them to a specific release. So here we also have an integration with Jira, for example, where issues can be pushed directly to a specific project in your Jira platform so that you can track it and follow it there. And this will give you a quick summary of all the of where the issue is found, information about the issue, and the ability to click back towards your issue. What's next? So we've looked at policy enforcement. We've looked a little bit at workflow and evidence. And the final piece that I want to share with you today is the ongoing oversight. And this is possible at the dashboard level. So we've introduced just recently project health dashboards and also customizable dashboards for all our enterprise level plans. So here, the purpose is not to fix issues. Developers are doing that already in the workflow, but instead we're answering a high level question like, are we trending toward or away from compliance? Is the risk increasing or decreasing over time? And are our controls actually working? So for leadership, this creates transparency without requiring deep technical involvement. And as I mentioned, if this is a standard project health view, but you can easily also create a duplicate of this. Let's call it a compliance dashboard for the sake of this demo. And here you can choose to also add or change different types of widgets, depending on what you want to include in your overview. So that could look anything from trying to see trends. So we know that our customers care a lot about trends and trying to see how this goes over time. So lots of things to play around with there. That reaches the end of my demo. When you put all of this together, you get a continuous system of controls. Policies are defined centrally, enforced automatically, evidence is gathered and continuously directly from the code. So that's what allows compliance to stop being a last minute hurdle and becomes a natural byproduct of how software is built from the ground up. And that's why why code quality, when done right, can be a true compliance accelerator. Thank you.
Hey, that's great, Simone. Thank you. And I'm so glad that you overcame those technical glitches at the beginning, because I think it's so cool to see compliance come to life in the solution itself. And thank you so much for that walk around, that whistle-stop tour around the SonarQube cloud there to see how we can leverage all the tools at its disposal from a compliance perspective. Thank you, Ekaterina, as well. That was great to take us through technically. Very tough slides to take us through, but thank you. Well done. I did just want to just draw your attention to the opportunity, if you wish, to find out more. Under the survey tab, you can leave your details and we'll get in contact to help you. Okay, so let's just quickly drop in a couple of questions. I've probably got time for one or two for either of you to answer. So AI is the topic of the moment, of course. And we see many developers using AI tools like Copilot, ChatGPT really heavily. So how would SonarQube specifically help us maintain compliance with code we didn't actually write ourselves?
I'll take this one. So again, when we talk about AI generated code and AI assisted code, it has to be assessed through the same lens that developer written code is assessed. However, and quality gates is the enforcement mechanisms that we have in SonarQube. It verifies this quality and security of AI generated code to prevent any sort of vulnerabilities from slipping into production. So uh, whatever standards you have for the developers, it will also apply to AI generated or assisted code. And in addition to that, as we've mentioned, AI code assurance and AI code fix as the features that will support you in flagging the AI generator assisted code in the review process as code that requires a more rigorous attention when it comes to review, and how the ways that you need to approach to get it to the highest possible quality.
Anything to add, Simone? Or
No, that was great. Greatly answered. Thank you.
great, then I'll go on to one final question. And we're often hearing how AI can speed things up, increase the velocity. Compliance, we sometimes hear, could be slowing us down. So how can we implement the checks, the kind of checks, balances, and measures that we talked about without actually hurting our velocity?
So I would say that in general, approaching code from the quality perspective, it does not slow you down. It supports the velocity because you don't do there isn't. It's not an extra step. It's a normal step in the development process to make sure that code is of high quality, and it automatically will check some of the compliance boxes. However, one of the approach that we think about in the context of SonarQube, for example, is shifting left and catching issues in the IDE. So a developer can avoid expensive rework, or whenever issue is slipping through cracks and ending up late, like mitigation costs, etc. So I would say that approaching the code generation from the quality perspective and adding the shift left, start left in our case with the SonarQube for IDE is the supporters for the velocity.
Okay, great, thanks. Awesome. Well, we have just gone over the 45-minute mark, so I'd like to say thank you to you both. Appreciate everything that you shared today. Thank you to everybody who's attended. Hope you enjoyed that content, and we will be emailing you shortly with the recording, so you can watch again. And finally, thank you for completing the survey. We appreciate your time and feedback, and we look forward to seeing you in our next webinar. Thank you, everybody, and have a great day.
Thank you very much.